So hello everybody, my name is Carola and I'm from a company that is called WPS in Hamburg. It's our central office, but we have offices all over Germany now, and I have a lot of colleagues these days. We started in 2000 with 12 people, and these days we are 170 developers, software engineers, software architects, UX designers, project managers, whatever you want. We started like almost 20 years ago to program with domain-driven design already. So our company has a lot of experience with that. And I fell in love with domain-driven design and with architecture right from the start. And did actually a doctor thesis on complexity of software architecture, and all that went into what I'm going to talk to you about today, just to put a little light on the other part of the name of this conference. It's not all just architecture, what we love in our company, but we are doing a lot of agile development, of course, as well. So, but today I will talk about architecture. And the first thing that we published was a book on sustainable software architecture, where sustainable is more meant like long-living software systems. And there was domain-driven design already in there, but this book is a lot about structure, what kind of structure you should choose. I'm going to say something about that. And then we went on and we headed into domain-driven design as well on the book market. And we translated a book from von Vernon into German that was called Domain-Driven Design, distilled in English and in German. It's this one. And then two colleagues of mine wrote a book about a technique that we are using to find out what the user really wants, how they are working. It's called domain storytelling. You will see that later on as well. Because all that went into our last book that is called Domain-Driven Transformation. At the moment, it's only available in German, but we are very sure that we will soon put it out in English as well, because the translation is done. We have really great reviews. Rebecca with Brooke looked at the manuscript, and everybody told us, yes, you should have an English version, so it will be on the market, I think, end of this year maybe or something. And what is domain-driven transformation all about? Well, it's all about horrible old software. And one picture that I really love to show you what these systems look like is this picture here. You see a castle, and actually if you look at that picture, you see that this castle, the original first castle, was built in a brilliant spot. You know, there is this river, you see this river going around, and there's a river too. So it's really the secure spot in this landscape to build a castle. And this is why everybody went there and wanted to live there, and the castle grew, you know. And this is what is happening with good software. You know, someone builds a very good little software system for something that everybody needs, and then the next person comes, oh, I need something too, please, please, please. And the thing is growing and growing and growing, and nobody has ever time to deal with structure, with how this should be, with the architecture or anything. And now we are there, even with Java systems that look like that, you know. When I came into computer science, pardon me, there was no Java, you know. We were dealing with COBOL systems and C# and stuff like that. No, not even C#, C++. But today, Java systems look like that too. And inside, you find structures like that. You know, this is a graph produced by a tool, you know, from a Java system. And all these rectangles are classes. All these connections are real connections. So one class uses something from another class, calls a function, uses some data, whatever, and the different colors came into this picture because we discussed with the architects their package tree, their modules, and we said, well, this one is the blue module, and this one is the orange module, and this one is the black one, the lilac one, and so on. And we put this color onto these parts of the system, and then we created this graph, which is in graph theory, this is a strongly connected graph, which means that all those classes need each other. You can't take anyone out. There's no one on the top that you could take away. And we call that cycles in our computer science language. So if you want to test that, you have to test everything, the whole thing. So it's quite difficult to grasp and understand. And if you see all the colors everywhere, this means that this cycle goes over about 10 different components of the system or modules. So this is what you find in systems that are old legacy and where people tell you, well, we better don't change it anymore, It's, yeah. So this is the problem, and clients of us call us when they have that. They call us and say, oh, Carola, could you come and help us? We have a problem with our software. And I asked them, well, okay, what do you have? And some people answer like, well, we have a huge Java system. Okay, how big it is? 3 million lines of code. Well, 3 million lines of code is okay, most of you have things like that, 500,000, maybe 1 million. There are systems that are really, really big, like 40 million lines of code. This is really huge, but 3 million is okay. You can have that. How many people are working on it? Well, we have 30 programmers. Okay, I say 30. Also a good number. They are fixing bugs and enhancing the system with new functionality. Yeah, but this is our problem. We are not able to program new features. They are all the time fixing bugs. And then I know, okay, you have a problem because this is too much, For a 3 million lines of code system, you need something like 10 developers who are sort of doing the daily work of fixing bugs, answering support questions and all that stuff. But you should have 20 people there that could create new features. And this is because they have something like that, something that in domain-driven design we call a big ball of mud, something really horrible. And that's the moment when domain-driven transformation comes into place, because what we want to do is we want to take this big ball of mud and transform it into something of smaller bits and pieces that are less technical, less cognitive load for the programming teams. And the most important point is less coupling. You saw it in the picture before. All that coupling that you have to think about if you want to change something. So we want to move from there over there. And Henning and I, my co-author of that book, we did that a lot for clients, other colleagues of us too. So we have different colleagues that are doing this domain-driven transformation, and we try to create some steps that we always do. So we could explain that to other people, and we could help them to do that themselves. So the first step that we are always doing, which is quite astonishing for the clients, is that we say we have to rediscover the domain. And we do that without looking at the software. I will show you in a second. So this is the first step. Then we try to determine the target architecture. So we discuss following this domain rediscovery, how the architecture should be. What is the goal? What is the target where we should head to? So what kinds of smaller pieces we are heading for. And then in the third step, we compare this target with the actual architecture, and finally we do the move. Step 4 is quite long, of course. Sometimes when I talk to managers, I try to explain to them that there is no magic powder, no possibility to do this and woohoo, the problem is solved, You did all that work to create that thing, Now we have to do the work to get there. It will not be much less. Okay, so let's have a look at those 4 steps. First step, domain rediscovery. Well, if you are familiar with domain-driven design, you probably know that there are various techniques to find out what the domain actually is that software is used in. And they are called collaborative modeling techniques. You might know event storming. Maybe you as well, domain storytelling. I will show you a small example. With domain storytelling, of course, it is small, it is reduced, it is not the real world. But the real world will never fit on this slide. So if you are from the car leasing sector, don't get mad at me because your processes are much more complicated. It's just because of the slide. So what we are talking about the domain car leasing, and we have the customer that needs a car. We have the salesperson that is happy to give a car to the customer, and we have the risk manager in that game. So the first thing is that we look at the different actors that are involved in this process, this domain, and the customer tells the salesperson what kind of car he wishes, and the salesperson prepares a contract. So here is already a lot of stuff missing because, of course, the customer tries out the car and all that. We just put it aside. So the salesperson calculates the installment for the contract. The customer signs the contract, and then the salesperson hands over the contract to a risk manager, because the risk manager has to check the credit rating of the customer, he has to calculate the real sale, and he has to vote for the contract so that the contract can actually be accepted by the leasing company, and then the customer can have the car he wanted. So this is a very high granular process of what the people in this organization are doing, and the people in this organization, they have a legacy system to do all that, but you don't see any computer, any system in there, and that's a very important point. When you rediscover the domain, you want to get back to the domain knowledge. You want to get rid of the software systems and anything that is there, because all of that has changed and influenced and moved words to another language that you don't want. You really want to have the pure domain, and this is what we are trying to do with those domain stories, or you can do it with event storming too, of course, or other collaborative modeling techniques. So the whole goal of this is to get back to the real domain and the processes that were in there. And when you do this, after a while, you see how subdomains emerge. And in here, we have 2 subdomains. We have the subdomain sales, and we have the subdomain risk assessment. And this is the basis for our target architecture, because our target architecture should be a mirror of the domain. This is where we want to go. So what have we found? We have found 2 in domain-driven design, you call it 2 subdomains or almost bounded contexts here, so risk management and sales, and probably in discussing the domain and creating other domain stories with the client, you will find some other subdomains, such as price calculation, probably something like risk reporting, we didn't see the domain story, but there is this part of the domain, and the payment probably as well. So we discuss with these collaborative modeling techniques the domain, and we really try to understand what are they doing, what are the bits and pieces of their domain. And then we have a context map. This is what it's called in domain-driven design, the target architecture. We have sales, risk management, and payment, and we start to discuss how do those different contexts work together. So in domain-driven design, there's a whole bunch of ideas about context mapping, and you find some synchronous here, like US is upstream and DS is downstream. I'm not going to go in detail what all this means. You can read that in any domain-driven design book. But the point is that you discuss the interfaces between those contexts, and then you look at the system that you have, and maybe the system is like this. We have module A, B, and C, and then we put these two onto each other. And we see, well, I created a horrible example. They don't fit together. You don't find those contexts in that software system, and then the work starts, and you're discussing refactorings and so on. And people always ask us, well, where are we? How far away are we from here? How good are we? Can you give us a number, a grade, or something? And this is why we started to invent something that we call the modularity maturity index. So a number between 0 and 10, and we tend to, when we are discussing the architecture with a team, we try to put them on the modularity maturity index, and if they are between 0 and 4, the software is very bad, very far away from the context map with a lot of cycles in there, so not in a good shape. When you're between 4 and 8, it's okay-ish, and when you're between 8 and 10, you're really good. So I'm gonna show you 21 systems we have measured. Today we are at about 300 systems that we have measured all over Europe and as well in America. And well, on the y-axis you see the modularity maturity index, and on the x-axis it's just the time. So the first one was this red system there, and the size of the bubbles is the size of the systems. So this one here down here at 4 has 612 million lines of code, and then there is this big one up there, 14 million. This is the system of the Techniker Krankenkasse. Very nice people of Techniker Krankenkasse are sitting here. I had the chance to look at in 2014, and then their system had 14 million lines of code, so quite huge. But the architecture was really, really great, a Java system. So if you are insured there, you can stay, it's a good quality. About the systems down there, I'm not going to tell you the names, okay? It's, but they are, it's not about language, it's not about the programming language, really, because this one down here is as well a Java system, It's just about, did the people understand what a good architecture should look like, and did they have the time to follow those principles and ideas, By the way, that thing up there, the best one, I think the big one up there, is a C# system that we found in Romania. So everything is possible in every language and everywhere in the world, And I have a lot of stories of all those poor systems and the good ones that came into this speech a bit. But I'm gonna show you now what we do, well, to get the modularity maturity index and to compare the actual architecture with the target architecture. Of course, we use tools, You see some of them here. And we do it a lot in remote sessions. Of course, we go there too, but if the company is far away, we do it in remote sessions. And if you want to calculate the MMI yourself for your system, you can. It's not a secret. The algorithm to do it and the measurements that we take to calculate this number are in the German book and in this English book up there as well. So they are published. You can do that yourself. So you remember we had step 3, comparing the actual architecture with the target architecture. And there we calculate the MMI. And one thing that became clear over time is when you're down here, you have a big ball of mud. When you're in the middle, in general, the system has a technical layering in there, you know? Like 5 years ago, when people called me, we have a problem, Carola, can you come and help us? My first question was always, well, what kind of architecture do you have? And until 2012, 100% was, we have a layered architecture, you know? We laughed about that today, but I remember the time when nobody was even talking about layered architectures. You know, this was in 2095, and then layered architecture was a great idea. It was great that somebody said, well, don't do everything like this, but just have a hierarchy. This is, you know, the other day I saw an old system where they still had, in the front end, they had SQL, so directly to the database. This was what we did back then, okay? So please don't always laugh about layered architecture. It's a very good thing, you know? It's great that we did that. But today, we want domain-driven modules. We want something that is cut differently, you know? And what we did is we discussed a lot. Well, how can I help people with a big ball of mud? I can hardly tell them to cut their system into pieces. This is not the best idea. But they want to get up there, you know. They want to move. So and they want to arrive at this, you know. They want to have a loosely coupled, wonderful architecture with domain modules, and in there some hierarchy and loose coupling, so not much coupling in between. This is the goal, where everybody wants to go. And the important thing, please, loose coupling. You know, we forgot about the coupling. Don't do all this event throwing around stuff. Really loose coupling means as little coupling as possible. Okay, so what are we doing? Well, with a big ball of mud, we can't go directly up there. So we have to start with other stuff. And we are doing 3 things here. We stabilize the system technically, we strengthen the domain, and then we're doing the 4 steps. And I'm gonna show you now how we do that. Well, a system that is a big ball of mud has a lot of bugs, low security and infrastructure, bad design, bad modularity. So the first thing that we do is this stabilization step. So we start to help them to automate their build and deployment, update frameworks. Out there, you can't imagine what they have, you know? They are still working with Java 1.4 and stuff like that. We have to improve error resilience, increase the tests coverage, and so on. So eventually we get to that state, and then we can move on. Then we can do something about the design, and details are all in the book or in other talks. We can enrich the domain model. We have to use value objects. We're going to resolve cycles and dependencies, and we have to reduce inheritance. I don't know why people think object orientation is about inheritance. You know, inheritance is the most horrible form of coupling ever invented on this planet. Don't do it, you know? Don't do inheritance if you can, you know? Get rid of that. in the domain source code, you know, in the technical source code. Okay, and then we can do the last step, and we can work on the modularity and do the 4 steps that you just saw: domain rediscovery, the target architecture, and comparing them, and do the move. So then we are in a better state. This is what we can do if we have a big ball of mud. Well, if we have a technical layering, it depends how the architecture is shaped, what you can do first. If you have to start with strengthening the domain and then the 4 steps, or if you can do it the other way around. The first path, you have to go if your architecture looks like this. You have some modules, but your domain model is a huge something. Everything is in one thing. And I'm gonna show you a little example from a client where we went the other day. I'm gonna explain to you what you see, but the first thing is, they called me and said, Carola, can you come and help? You know that already, you know? And I said, yes, I can help. What do you want to do? I mean, what do you need help for? Well, we want to cut our systems into microservices. I said, possible. We do that all the time. How much? Which language? Well, 1 million Java. Oh, I said, okay, well, it's big enough to have 3 microservices, or 4 maybe. What is your architecture like? And I was expecting technical layering, but they said, well, our architecture is following use cases. Oh, I said, this sounds like something from the domain, use cases. Yeah? Okay, I said, and we went there with our tooling, and we put the system into our, these tools all work like that. They have a parser, and the parser is parsing the source code and creates a structure of all the classes, packages, whatever, how they are connected. And then you put your idea of the architecture on top. And this is what you see here. You see these rectangles. Those are the architecture elements that we created. And we created them with the architects together, following their idea of use cases. And then we put parts of the system into these elements, into these use cases. So there is a use case: mailing, import, export, remove. You see them. It's not the real names. So you can already imagine that the story will end up not positive, but anyway. So all these things up there are the use cases, you know? And then we came to that thing down there that is called model, you know? Model here. And I said, oh, what's that? And he said, well, this is the domain model, because we started with one use case and then we created the product, the contract, whatever you want, the client class, and they are all in there. And then we reused them. I say, well, if you want to have microservices, you have to cut this model thing as well and put the classes into the use cases where you want them. And I asked him if he can imagine that we do. Yeah, we could. And before we go to the next, where you see the result, we look at the other side. And there you see those arcs. Those are the connections that are in the source code. Because if you click on the plus in front of mailing, the package tree and classes will appear. So in there are classes, and in all the others as well. And these arcs represent the calls from one class to another. So in mailing, there are some classes that are calling import export. On the left side, the green ones go from up to bottom, and the others on the other side, the other way around. But it's not important if they are red or green, just the direction. So remove is using import export. So we started to move classes from model upwards, you know, into the use cases, because we wanted to get rid of the model thing, you know. And after, I think, 40%, we ended up with that, you know. Now you see all the coupling that is in the domain model in there, you know, and that is moving, creating all those connections. So this is quite impossible to cut that into pieces, and this is why we started with them as well on the bottom level. We had already quite a good security and bug result, but we started to do the strengthening of the domain first before we could do the 4 steps to change the thing. If you have a layered architecture that looks like this, where there are already separate domain model pieces, then you can do it the other way around. So this is the second possibility. Then you can start up there and do the 4 steps first, which is a very great possibility, because then you cut the thing into bigger chunks, and then you can strengthen the domain after that. So this is the better situation, but you don't find that often, because software developers love so much to reuse. And if there is a product class or a customer class or whatever class, we love to reuse it. But this creates this huge entangled domain model, and that's the problem. And when you're up there, it's wonderful. You can just do the 4 steps, and you've done the job. While doing that, we found something that I want to show you just shortly on a slide. We found that domains are differently. It's not easy. There are some domains that are very easy to cut, and others that are much more difficult to cut. And we have given them names. So we have seen domains where the work is done step by step. Some role is the first one doing the work, and then he hands over the result to the next person. And they are doing something, and it goes on. And we've called them pipeline domains. And this is what you find in insurances, in administration. So this is something that is easy to cut. But we have seen as well other domains. We have seen domains that look like this. So all the different roles are working together on the things they are producing, and there is no separate steps. We have called them blackboard domains because they are all working together and on a blackboard. And these kinds of domain, I have no idea how to cut them, I have to admit. So before thinking about cutting your domain, ask yourself what kind of domain you have. There is a bit better version of the blackboard domain, which we call a dialogue domain. This one is easier to cut. This is one where people discuss a plan and have some kind of quality gates to do that. But this one in the middle is really, really difficult. I saw that when I saw some software to calculate car prices, where everybody is changing something all the time, or huge machines, when you want to produce these huge machines, you have to calculate all the bits and pieces, and you can't hand something over. And this is why on conferences in talks about cutting domains, you will always find pipeline domains as an example. Nobody will ever show you an example on a blackboard domain, because this is I even don't know how to do it, And to finish up, you will probably have a domain that is cut into subdomains, and you will have maybe a pipeline on the top, maybe. Maybe in there is a dialogue and a blackboard and another pipeline, and in there is a dialogue and a pipeline again. So you can, of course, have all kinds of varieties on different levels. There is no question about that. So now I hope I showed you something and it came across, and I'm ready for questions.
Thank you. I will just join you up there.
Oh, yeah.
Then you don't have to look downstairs
so much. Oh, that's so nice.
Okay, so we have got a couple of questions again. At what point do you need a complete rewrite of the system when you can do the incremental refactoring?
Yeah. Well, actually, I'm a big fan of using what is there and working on it to get it into a better shape. You know, I think there are not many reasons to really do a complete read-write. One reason, of course, is when the technology will not be available in the future. You know, I have been in companies where they were still using some old 4GL sort of environment, and nobody would support it anymore. You need support for your platform. So this is a reason. And the other reason is, of course, you don't find any developers anymore for that technology, or you want to attach young people to your company. Then you should do a rewrite. But all kinds of rewrite I have ever seen in my life were much harder than the people expected before or calculated. But I mean, in Hamburg we even have buildings like Elbphilharmonie, so you can finish it. But yeah,
well,
yeah.
Talking about buildings not finished, you are in Berlin, you know about airports and so on. Okay, your analysis looks at connections between classes, but what about data access, API calls, messaging, event handling, etc., etc.?
Yeah.
These are implicit.
So tools are standard. I mean, tools that you can use for these kinds of architecture review and analysis of the MMI. They can analyze source code. You know, this is what they can do. And if you want to integrate other kinds of connections, like events, whatever, you have to find means to do that. But most of these tools, they offer you an API where you can, for example, import some XML files with some structure that create connections in the database or in the structure of that system. So you can enhance it, but it's not. There are no automated solutions that I know of. If you know, please tell me. But in general, there is some work to do. But you can, of course, look at other connections, and we have to do that with microservice architectures. Of course, we have to do that. We have to see the hidden connections in between. So absolutely, yeah.
Mm-hmm. And now a good one. In 5 years after the transformation, how can we prevent the big ball of mud from reappearing?
Very, very good question, perfect question. Well, what we have to do is we have to look at the system regularly. One thing that you should all do, if you have an idea of your architecture, program it into Arc unit tests. You know, use this tooling to have a constant testing of your architectural rules. So then you prevent that the thing breaks apart. And what we of course do as well, that we regularly look at this system with those tools to find out if the thing is still enough. Okay. Oh no.
Okay. Thank you.